All righty, geometry. It is Thursday, May 1st for you, but it's actually Tuesday. Got my hair cut and my hair is kind of messed up right now. And went to the barber today on the same day we had our last day of NHA on Tuesday. I'm recording this on Tuesday, and but you're watching on Thursday, May 1st, which is my birthday. So happy birthday to me. And lesson 78, we're going to get a little bit more into trigonometry, and I'm going to show you a little bit about tangents today. Again, I told you the sines, the cosines, and the tangents. Those are ratios involving trigonometry. And again, it's really easy now because all you got to do is throw it in your calculator, or even if you have an iPhone, and showed you those buttons on your iPhone today, and or if you have a scientific calculator. And so let me just show you some more things. We just kind of introduced the idea of trigonometry from a ratio standpoint on Tuesday, which is today for me, but 2 days ago for you, if you're watching this on Thursday. And I'll know how many of you watch because it'll tell me. And so I'm expecting you all to watch. And let's go to the white screen here. And let's do some figuring. So today we're just going to learn about the tangents. And it's the tangent ratio. Okay. And we'll show you how that works and how you throw it into it. And I'll pull my calculator up on my computer to show you. So let's just go ahead and take a right triangle here. And we're going to call the hypotenuse always the hypotenuse. Now, tangent is opposite over adjacent. Now, I'll tell you what all those words mean here in a second. But that's the ratio for tangent. The sines and the cosines will be different ratios, but this is the tangent ratio that we're talking about today. So, well, how do you figure out which is which? In this one, we're going to say that this is, you could choose any degrees that you want to. Let's call it 55 because I think that's what they call it in your book. Okay. So, in this particular instance, we're going to call this, so the hypotenuse is still the hypotenuse, but you have a leg and a leg. But you need to make sure that you have the one of those legs as the opposite and one of those legs is the adjacent. So how do you figure out that? Okay, so, well, in relationship to the 55-degree angle, we say that this here is the opposite and this here is the adjacent. So this angle here, we could call this, I mean, if you call this triangle ABC, angle C is 55 degrees, and the tangent of angle C is the opposite over the adjacent. And so again, all you have to do is, and I'll show you how to do that in a minute, but I'm just kind of laying out to you how this works. So the adjacent one is the line. Now we're talking about the line segments here, not the angles. So angle C is right here. That's 55 degrees. Of course, A is 90 degrees. And this would be what, 35 degrees? Because 35 and 55 would be 90, right? So in this capacity, angle C is, it's like basically saying tangent 55, okay? And I'll show you how to throw that in your calculator in a minute. If you were to do angle B, it'd be tangent 35, but this would now be the opposite. Because here's 35. This is the opposite of the angle you're using. And this would be the adjacent. So here you'd have AC over AB. So the tangent of 35 is AC over AB. And I'll show you how to do that in a second. I'm just kind of laying this out for you. Okay, so now let's go ahead and give you an actual example of one. And we'll call this, I'll just use the example that they used in your teaching textbooks. Okay, we'll call this the right angle. We'll call this JKC. I'm not sure how they came up with that numbers. They're going to call J 28 degrees. I apologize if this is not. Okay, so we're going to go tangent. So this is the hypotenuse. This is going to be the opposite here. And remember, the tangent is equal to opposite over adjacent. Okay, I'm going to show you exactly how to do this. Okay, So the opposite is KC, right? Oh, by the way, in the illustration, they gave you a measurement for KC. Okay. So we can actually solve. So if tangent is equal to KC over JC. So tangent 28 is equal to KC over JC. Well, they gave us KC. Go tangent 28 is equal to 3 over JC. It's all. Now you have to give me a value for this. Okay. So this is how you do it. Let me go to the, I got to stop this right here. Actually, I got to pull up my calculator. And then I have to share my calculator. I'm going to lose the whiteboard for a minute when I do that. Okay, so now watch. I was practicing early. So we said that the tangent's 28. So you say 28, you can do it either way. You can put tan 28 or 28 tan, either way. So whatever this value is, 0.53, and again, they have you round it, and where they round is just different. Sometimes they put the whole thing together, and I'm rounding incrementally as I'm going. They kind of show you to put it all in your scientific calculator and press equals at the end, and because of that, there might be a to the 100th place difference of 1 or 2 digits, and I'll show you how that works along the way. Okay, so this is 0.53. We'll just call it 0.53. Okay, because we're going to round it right now. Again, it's going to be slightly different because they pull it all the way in there, and at the very end it rounds. I'm going to round it right now to the 100th place. So 0.531. So let me show you how I did it. The degree of the measurement was 28 degrees. You put tangent first, 28. Okay. Once you do that, you just press equals. It gives you a value. Whatever value that is the value you use. Let's go back to the white screen and I'll show you how that works. And this is actually not too, it's actually, as I told you on Tuesday, you just throw in numbers in the computer or your calculator and it's just, you're not even solving that much stuff. The trick is to make sure you lay it out correctly. And so let's go back to the whiteboard and pressing the wrong buttons here. Okay. So tangent 28, I said was 0.53. So instead of this tangent 28, I'm just going to write the numbers that it produced for me. 0.53. I'm going to call JCX because that makes it easy. That's what we're solving for, right? So I'm just going to, instead of saying line JC, I'm just going to call this X. So now I have to do is cross multiply. So I have 0.53X is equal to 3 divided by 0.53 divided by 0.53, and you're going to get X or JC is equal to 3. Oh my God. You have your phone on you, babe? I just want to calculate. My phone's upstairs charging. Look at my wife's phone. She might wave at you. She's very pretty. Have you ever noticed how pretty my wife is? She's a beauty queen. Yeah, Mr. Soto, how did you get a beauty queen? I tricked her. I said I was handsome. She believed me. She still believes me. 30 years of marriage. Where's your calculator, babe? I use my calculator all the time. You don't even have the fancy calculator on here.
They're not ever using calculators.
Hold on.
What would I use a calculator for?
Don't want that. Scientific. There we go. All right, we got the scientific calculator there. Okay, so now I'm just going to go and again 5.66. 3 divided by 0.53. 3 divided by 0.53. Yeah, 5.66. So that's your answer right there. So JC is going to be 5.66. And again, if you throw it all in there and then press equals, you can do that. And you're going to be just this 100th place will vary, just fluctuate because it rounds earlier when we do it the way we did it. And but anyways, so 5.66 is how you get that in. And so that's all you got to do. Piece of cake. We'll one of those in the examples. So, and they have these charts, but you don't have to ever use the charts. Again, remember I told you when the Greeks were doing this back 2,500 years ago, they took all these numbers and they had them all listed out, and then they'd go through the sines, cosines, and tangents. Your calculator will do all that for you. So let's go ahead and go through these lessons right here, and I'll go rather quickly just because you're wanting to be done with NHA and I'm not. I'm wanting to teach more, but I'll acquiesce to you. Number one, from a particular right angle in a right triangle, the leg that connects the angle is called the adjacent side, and the opposite, that angle is called the opposite. That's true. That's what I just showed you. Two, the only place to find a trigonomic ratio is in a table. No, your they have the tables, of course, and you could scan those. And I bet like 40 years ago in trigonometry, they'd give you this big old chart. You'd have to go down and have to go, 28 degrees tangent is, whatever but you don't have to do that anymore. You just throw it in your calculator. So that would be false. And so number three, and you can always pause these, do the answer, then I'll give you the answer. So let's try that. Okay, I'll just go through these quickly. I'll have a brief pause long enough for you to pause your device, and then you can give me the answer or check your work. So number three, the tangent ratio of a particular angle in a right triangle is the blank to that angle divided by the blank. So pause it. You can look at all those answers. A, B, C, D, or E. And did you choose D? The opposite side divided by the adjacent angle. Opposite over adjacent. The tangent philosophy is opposite angle over the adjacent angle. Tangent equals opposite over adjacent. All right, so that's letter D. Number four. A segment that is both an altitude and a median of a triangle is okay, remember, an altitude makes it perpendicular, and a median cuts it in half. So it would be a perpendicular bisector. Usually that's on equilateral triangles, right? In order for it to be an altitude and a median, have to be a perpendicular bisector. I don't know if I paused it long enough for you to pause yours. I hope you did it. I might have been too fast on that one. Number five, the diagonals of an isosceles trapezoid are an isosceles trapezoid. Diagonals would be, pause it. They're just congruent, letter C. They can't be perpendicular. They can't be parallel for sure because they bisect each other. That would be silly. It can't be a perpendicular bisector because they're not perpendicular, and always longer than any side. That actually kind of makes some sense. But anytime you see the word always, that's an indicator that even though it almost oftentimes is, doesn't mean always. So to me, an indicator, the word always or never, those super superlative words are almost always, there's one of them, indicator that it's not that. And those are trick words in testing. All right, so let's go to number six. We're flying through this. So number six, remember this is the formula. It's 180 n minus 2. That's how you find the sum of the angles, interior angles of any polygon. Okay, n represents the number of sides. So for number six, it looks like a 1, 2, 3, 4, 5, 6-sided shape, which is a hexagon. So you put sixes in and you solve. So we have 180, 6 minus 2. There's my dog. Did you want to see my dog? Max, remember he was dying and you all prayed, you were considered. Max. Max. He's deaf. You were very concerned and compassionate for him, is how I meant to word that. And so 180 times 4 is, I believe, 720, right? 4 times 0, 32, 4 plus 3, 7, 720. So there you go. Why don't you try number 7 on an 8-sided octagon? Again, the n is the number of sides, so you put an 8 there. Try that one. Pause it so you give you a chance to do it, and then I'm going to write it here. All right, you're back on now, so you have 188 minus 2, 6, 180, 180 times 6, 0, 48, 6, 1080. 1080. The sum of the angles in a octagon. And it doesn't have to be a regular octagon. I mean, if it's a regular octagon, you just divide this by 8 and you know what each angle is because they all be the same. Here in this octagon, they're not the same, but the sum of all of them will be at 1080, even though some angles are different. But if it's a regular octagon, then it would be 1080. All right. Let's do number, I'm gonna lay out number 8 for you, then you're gonna do it. We have right triangle PRQ. So let me just draw a right triangle. Let me get the information it has here. It says PQ is the hypotenuse. So R must be where the right angle is. Okay, right? If PQ is the hypotenuse, it's PRQ is the triangle. And they said that angle P is 58. Okay, so we have 58 here, 90 here. We know this is going to be 58 minus 90, right? So we know this will be the smallest angle. Okay, it says, what is the shortest side? Remember, the smallest angle produces the shortest side. Remember that? So we know that the longest side is the hypotenuse. The middle side, because 90 minus 58 is 32. So this is 32. Since 32 is less than 58, 32 is the smallest angle. Angle Q is the smallest angle. Since angle Q is the smallest angle, PR or RP, either one, is going to be the smallest side or the shortest side. All right. Why don't you try number 9, and I'll lay it out for you there as well. Okay, so let me show you what we did here. I hope you did this right. All I'm saying is this plus this plus this is going to be equal to 180 because that's what they said. X plus 10 is angle B, 3x is angle C, and X is angle E. So I combine like terms, X, 3x, X is 5x, plus 10 equals 180. Subtract 10 from both sides, 5x equals 170. Divide by 5, X is equal to 34. Well, C is right here. So now I just have to, I solve for X, plug it back into 3 times X, which is 3 times 34, which I've already done right here. There's your answer. That is the measurement. And then that puts the longest side as BE because this is the biggest angle at 102, right? So 102, because this is going to be 44. This will be 34, 44, and 102. And so it makes BE the longest side of that particular triangle. All right. Number 10. We need the hypotenuse. So we have 49 plus 196 square root equals, I think they actually want it in a reduced fraction. So let's do this actually. 245 root. Let's go ahead and let's just do a factor tree on this. C squared equals 245, right? Because you say 7 squared plus 14 squared, 245. Then you root both of those. C equals the square root of 245, which is 15 and some change if you're using an approximate. But let's do it in a factor tree because that's the way I think they want you to do it. So let's see what the best thing to put in here. I could just put 5 to start with. That just seems like a lot of work. No, it's not. So 7 goes out, 5 goes in. There's your answer, 7 radical 5. Again, factor tree, 245, 5 times 49 is 245, 49, 7 times 7, perfect square. So again, let me just clear this off just a little bit to do one extra thing to see it. I think you know how to do this. It's 5 times 7 times 7, 245 reduced to a product of its prime numbers. Remember I told you like 2 years ago, some of you guys, you need to learn how to do this factoring tree because it's going to come back in math a whole bunch. And some of you listen to me. You all listen to me. And because now watch, 2 7s come out once, right? By definition, a radical sign. Since there's only one 5, it's got to stay in. And your answer is right there, 7 root 5. Why don't you try number 10? It works the same way. I'm going to start doing it right now. You can pause it if you want to. I'm going to do it, but I'd like for you to try it. Let me see. Did I do something wrong here? Let me see if I did something wrong. Three. Okay. Must be the correct answer. 329. There you go. Yep, that must be the right answer. 3 root 29. Looked a little funny to me, but that should be the right answer. And all right, let's go to number next. I hope you got that answer too. That's the answer I got. Pretty sure it's correct. I could double check on the score key. I should get a hash mark for that parallelogram I just drew. That thing was pathetic. That one's not much better. It's better, but not that much better. So we have A, B, C, D. Okay. We learned this last week. Okay. Remember these 30, 60, 90 triangles? This here is double this one. Remember? Because that's when we did the equilateral triangles and then we split it in half with an altitude. And I showed you like if it was like this, if this was an equilateral triangle, and you split it in half. If they're all 2, 2, 2, this whole thing's 2, so this is 1 and 1. So we know in any 30, 60, 90 triangle, this is going to be, the hypotenuse is twice this short leg here. So this will be 6, and then this is 3, since it's a parallelogram, this is 6. That's pretty easy, actually. And then I think this is like 3 root 3, but we don't even need to have that because that's that middle leg. So all we need is the hypotenuse. So 3, remember this, if this is 1, then that's 2. And we learned that on maybe last Thursday or last Tuesday, a week ago. So 6 and 6 is 12. 12 plus 6 is 18. There's your perimeter of the polygon for number 12. Boom, chugga, chugga, chugga. All right. Let's go to number 13. I'm curious to see if that's 329. I want to kind of look it up. I'm pretty sure it is. It has to be. They want the perimeter of this dude here too. Let me show you how to do this. Okay, don't confuse yourself. This is not a 30, 16, 90 triangle. But what it is, and by the way, just so you know, remember the 3, 4, 5 triangles, kind of a basic one that you learn. 3, 4, 5 is a right triangle, and it's always perfect because 3 times 3 is 9, 4 times 4 is 16. 16 plus 9 is 25, and the square root of 25 is 5. 3, 4, 5. That's a perfect right triangle, right? But any of its multiplied counterparts will also work out. So you see a 3, 4, 5. Well, look at these two legs are 6 and 8, which is 3 doubled is 6, 4 doubled is 8. I mean, you could have figured that out if you want to. You could go 36 plus 64 equals 100, and the square root of 100 is 10, right? So that's 10, that's 10. See how I got 10 there? So it's 36 plus 64. Or you could realize that the 3 and the 4 doubled are 6 and 8, and 5 doubled is 10. You'd see how it works out right there. So those two are 10, 10. Okay. I just need to find these three sides. This one, and this one. Well, this one's going to be 12, right? This is 6 and this is 6. That's 12. Since this is 12 and 13, this is another special triangle. It's a 12, a 5, 12, 13 triangle. That's what they're called. I'll show you why it's that way. 5 times 5 is 25, right? 12 times 12 is 144. 25 and 144 is 169. And the square root of 169 is a perfect 13. So because of that, they didn't give you this. You could have solved for it if you wanted to. But this, again, these are ones. The heck. Okay. So if you needed to solve for this, you could have done this. And I'll show you how you do that. It's a squared plus b squared equals c squared. We have the b squared at 144. We have the c squared at 169, a squared. Subtract 144 from both sides. A squared equals 25. A is equal to 5. Okay, so you could solve for it that way. But again, these are some that 5, 12, 13 is just another perfect right triangle without like a radical or irrational number, which a lot of them have those. But these, like the 3, 4, 5 and the 5, 12, 13, there's about 5 or 6 of them that are that. So that's 5, then this must be 5 also. So 10, 20, 30, 42. There's your answer. 10, 20, 25, 30 plus 12 is 42. Piece of cake. Okay, so for number 14, all you have to do, check it out. I'm going to go back to my calculator. Pull it up. Actually, I need to share that with you so you can see it too. All you have to do here is this. This is easy, cheesy, lemon squeezy. 22 tan, or you can go tan 22. Either one. Doesn't matter which order you do it in. They said they want it to the 4 places past. 4040. There's your answer for 14. Try 15. Just take your calculator, put tan 68 or 68 tan. Either way, it's going to lay it out the same way. There it is. Go to the, what is that, the 10,000th place rounding? 2.4751. Easy cheesy lemon squeezy. All right. So let's try one of these here that's actually going to be um, and again, you might be a hundredth off one or two because of how and when you actually round, and that's okay. So we're gonna have, so this is the 30, this is the X. It's, remember, tan is opposite over adjacent, right? Opposite is going to be 10. Okay, this is the hypotenuse, this is the right angle. So it's tan 30 is equal to opposite 10 over adjacent, which is X. So throw tan 30 into your calculator. I try to run the whole thing, see what happens. Don't like that, actually. Let's go, just go tan 30. This is not working right. I must be putting the wrong button. Let me do it on my calculator here. I'm gonna try it this way. I think I have a button pushed on this calculator. Let me our dog's choking. He's dying. 30, 10 equals. Okay, there we go. The phone wouldn't work. So it's gonna be 5.77. Now I want to go back to the white screen. So again, so don't know why it wouldn't work on the phone. So instead of tan 30, you're going to put 5.77 times X, cross multiply, right? So this is 5.77 over 1. So you cross multiply, X equals 10. Divide by 5.77, divide by 5.77 is going to give you, back to the white screen. Let's see if I can make this work. I mean, back to the calculator. Divided by 10 equals, actually, I want to go 10 divided by, you want 10 divided by, let's see if we do 10 divided by tan 30. Okay, yeah, that's the correct answer. 17.32. So let me show you one more time. Look what I did here. 10 divided by tan 30. Let me show you why I did that. And erase some of this basura here. Where's the eraser at? Oh, there, right there. Okay. Okay. So you saw the answer already. I'll just show you how you put it in the thing. It's tan 30. Tangent is opposite over adjacent. This is the, since this is the 30, this is the opposite, 10 over X. So it's tan 30X equals 10. So after you divide both sides by this, tan 30X, tan 30X, and let me see if I get the calculator to do it. Now, it didn't do it before. And let's see if I, dumb calculator. 10 divided by tan 30. Okay. 10 divided by tan 30 equals, yeah, there's some other setting on this and it's not working on here. I'm not sure why. Oh, it's got this RAND setting. That's why. I'm not sure how to undo that. Yeah, I'm not sure why my wife's phone's doing that. I pushed a button and it keeps on messing things up. Let me just go back to the calculator real quick on my computer. 10 divided by tangent 30. 17.32, that's the answer. All right, why don't you try to do number 17? And I'm going to show you one thing about that one really quick, though, before you start. Okay, on this particular one, let me draw the angle for you. That's the hypotenuse. Okay, here's the 51. Tangent is opposite over adjacent. Okay, well, the adjacent is now on the bottom. Okay, so it's going to be tangent 51 times 18 is equal to, so you don't even have to divide. You just tangent 51 times 18. Try that and you should get the right answer. Tangent 51 times 18 is equal to x, which is the opposite, which is the letter y. I push a bit y there because they have y in the illustration. Okay, so tangent 51, because tangent is opposite over adjacent. Well, you're going to cross multiply this. So tangent times adjacent equals opposite, which is just y. And once you lay these things out, it's just like, it's really not that difficult, as long as your calculator works right. Tangent 51 times 18. Again, I need to go, I think you need to go actually tangent 51 equals times 18. Let's try that. Because it had that in there, and I don't want that. There, that's the correct answer. Okay, so let's do that again. You have to actually solve for the tangent first. 51 equals, then multiply that by 18. There you go. 22.23 to the 100th place. That is the correct answer. All right, I'm going to let you finish number 18 on your own. You all know how to do those, solving for x's. And so you should be able to do those. And that's it. That's Geometry 2024-2025 school year NHA. And we are absolutely DONE for the year. I will taco to you next year. I might see you at graduation, some of you. And Mr. Soto saying, peace out.